Madam, you can start now.
Good afternoon, everybody. Welcome to the 16th talk in the MoES webinar series. As you may be aware, this series was started amid the crisis of COVID-19 to showcase the new methodologies that support the Ministry of Earth Sciences Reach Out activities. So this is the 16th talk, but before that, you've heard talks by experts in different aspects of earth sciences, ocean technology, and precipitation, weather forecasting. This particular talk is on thunderstorms and associated phenomena such as lightning, dust storms, etc. So at the outset, I would like to thank the Ministry of Earth Sciences for permitting me to talk on this subject. It's a favorite subject of mine. And I would like to thank India Meteorological Department, Indian Institute of Tropical Meteorology, and the team who are dedicated to making this a trouble-free experience for all of us. So what will I talk about in this talk? We'll talk about what are thunderstorms, what are the associated weather, and forecasting of thunderstorms. It's a real big challenge because thunderstorms are not very large-scale systems, and missing out on their weather is often the norm. And the final part of the talk will be on actionable warnings. This is something that is more important for the general public. If we say there's a thunderstorm, what should you do? So keeping that in mind, we will try to finish the talk within 60 minutes, and I'll welcome any questions during the talk, which can be addressed at the end of the talk. Having said that, I think I will go for sharing the presentation. So this is the title of the talk. This is the final talk of the webinar series. I'm lucky in the sense that there have been experts who talked on the background to what are thunderstorms in different ways throughout the past 2 months. But I don't know how many of you are aware that WMO has declared an International Lightning Awareness Day on June 28th. If you see on June 24th, there was a news item that they have finally acknowledged a mega flash, a huge lightning flash of around 700 kilometers over Brazil in October 2018. Simultaneously, they've also acknowledged a record-setting length of a thunderstorm, which is 17 seconds. So when you talk of a 700-kilometer long mega flash, lightning flash, just to give you a perspective, maybe it is as long as a thunderstorm extending from Delhi to maybe Balia or wherever you're staying. You can imagine the length, and accordingly, you can imagine a single flash, single lightning flash of this magnitude. Along with this, on June 25th and 26th, there were also some reports you must have read in the media regarding lightning strikes in Uttar Pradesh and Bihar. 110 people have died in these lightning flash strikes. 32 people have been injured. And the picture to the right shows the frequency of lightning strikes over a 24-hour period over East Uttar Pradesh and Bihar region, which really caused this kind of devastation in these regions. So what will be the layout of this presentation? The layout of this presentation will be basically what are thunderstorms and associated phenomena. Obviously, they're not to be taken lightly. Forecasting of thunderstorms, as I talked to you about, and the final will be the actionable warnings. So what are thunderstorms? That is the first question that we face. WMO defines thunderstorms as one or more sudden electrical discharges manifested by a flash of light and a sharp rumbling sound. Now that is a scientific way of describing a very commonly observed phenomenon. What we see as common people of thunderstorms is when we hear the loud rumblings in the sky and we look up to see huge thunder clouds in the sky. Now this audibility of thunder means that given the range of human ears and the intensity of the sound produced in a thunderstorm, it is about 20 kilometers around an observer. If there is a thunderstorm, that is detected by an observer. Associated with thunderstorms, as I talked to you about, we have lightning, which we had seen has recently caused a lot of devastation. We have high winds. Now, this is again something that, again, after every thunderstorm event, roads need to be cleared, tree branches, electric poles damaged. Hail. Now, hail is a major phenomenon that really causes a lot of devastation. We'll talk more about it. This is a picture from Chhattisgarh last month. And you can see corrugated tin roofs have been totally damaged simply due to hail. You have dust storms. Now, dust storms are this kind of huge walls of dust is one thing. But as it is, if you have ever, as you may have witnessed in the central parts of India, North India, and interior peninsular India. This is pretty much the beginning signature of thunderstorms during the months of March to June. And of course, rain. Rain is not something we are dealing with in this talk, but there are associated with thunderstorms, you have, especially during the monsoon season, you have severe rainfall episodes. You just had a lot of rainfall recently in Bihar and Assam and Meghalaya. So this is also associated with thunderstorms. Not to forget, you have damages, deaths, and loss of property. In fact, if we try to see this in more concrete terms, you will note that this picture shows around 2,000 to 3,000 people die every year from thunderstorms alone. So that instance of Bihar is not an isolated instance. It is an annual phenomenon which we need to be aware of. And another fact to note from this is pretty much the frequency of deaths and damages is increasing year by year. Talking of economic losses, there is this increasing curve. This also I have collected from a particular paper, but this is showing there is a gradually increasing trend in frequency of damages from economic losses from natural disasters. So when we talk of thunderstorms and the associated phenomena, and borrowed this particular classification from, of course, this is a standard classification, but Dr. Pandithurai in his talk also talked about them. We are talking of clouds that start in the lowest part of the troposphere. So, and cumulus and nimbus categories of clouds are more important for thunderstorm formation. When cumulus clouds, those are the small little bubbles that you see in the sky, clear weather cumulus clouds. When there is enough moisture or conditions are suitable, these start to mature. And mature means they grow to form cumulus congestus clouds. These are large popcorn-shaped clouds. In fact, if you see behind on the background screen, this is a pretty much cumulus congestus cloud. But that doesn't stop the life process of thunderstorms, of clouds. They basically mature into cumulonimbus. Cumulonimbus is a more developed version of the cumulus congestus cloud. So this is basically a picture of what happens. You have the shallow cumulus, the Cumulus Congestus, and the cumulonimbus. Cumulonimbus is defined with an anvil cloud. Of course, the length and the breadth of the anvil varies from the season to season, but nevertheless, there are tall clouds with a lot of ice inside them, and there is a possibility of lightning, hail, high winds, whatever we see in thunderstorms. And these are basically the clouds which are the observed thunderstorms over the region. This is that popcorn-shaped cumulus congestus cloud I was talking of. In clouds, in fact, from this stage onwards, rain starts, your lightning may also start, but only after they reach this kind of cumulonimbus stage, you start to get the other phenomena such as strong downdrafts, hail, high winds, and lightning, more frequent lightning. If you see the climatology of these thunderstorms, globally, not globally, but the Indian region, if we see, this is the annual thunderstorm climatology. You see there are three main zones of thunderstorm occurrence. One is over, on the annual scale, one is over Jammu and Kashmir region. The second category is maximum is over this region, basically, Bengal and Northeast India, Bengal, Bangladesh, West Assam. And the third is over Kerala. If you go by a seasonal scale, by season we define, say, the winter season, which is January and February, you'll see that the three maxima do not appear necessarily in the season. There are only two maxima. One is over this Jammu and Kashmir region, one is over Kerala. In March, April, and May, if you see these thunderstorms, this two, in addition to the two maxima, a third maximum appears over the Gangetic West Bengal region and neighboring Orissa. During June to September, the thunderstorm frequency is highest over the Himalayas, but slightly to the east of what was in these two pictures. So it is more over eastern parts of Jammu and Kashmir and associated Uttarakhand and Himachal Pradesh. The southern peninsular maximum has vanished, but the East Indian maximum has increased in intensity. Coming to October and November, which is the post-monsoon season, the maximum over Kerala has reappeared, not just Kerala, but entire extreme south peninsula, Tamil Nadu and Kerala. And this is also the time for northeast monsoon over this region. This peak has decreased in intensity and this is also decreased. And together, when you see annually, you have the three maxima over the three regions. This is highly stable across studies. We have found that this is pretty much the picture throughout the over the years. We have with us if you compare the thunderstorm and lightning, because we are defining a thunderstorm in terms of lightning and hard thunder. Both are necessary for defining a thunderstorm occurrence. This is this is the lightning frequency over the Indian region. This is January, February, March, April, May, June to August. They've mentioned whereas we take it as June to September. But nevertheless, if you see the maxima are pretty much matching. The lightning maxima are pretty much matching with the thunderstorm maxima. So because of this, we can also say that from two different sources we get a similar result. So pretty much these are the three maxima for thunderstorm occurrence. Why do they occur? So let's talk of winter season. This is again a picture for total precipitable water. If we take, you'll note that these bluish colored tinges are all dry regions, and only in the green regions you have some moisture coming in. So If you see the entire Indian region, there is low moisture. Not much moisture is there in the winter season, January and February. If you see the temperature, this is 1.5 kilometer high temperature, and this is about 5.8 kilometer high temperature. And if you see the difference between the two, that gives you an indication of the lapse rate and the instability of the atmosphere. And what is the clear, maybe not from this, actually the writing is pretty small, but the atmospheric lapse rate is very low. Low means that the atmosphere doesn't have much conditional instability within it. So localized formation of thunderstorms is inhibited. This is the wind field again at 1.5 and 5.8 kilometer. You will note that in the upper levels there is a subtropical westerly jet, and that basically results in high wind shear over North India. Over South Peninsular India, if you see in the lower levels, there is the easterly waves. So that is why these easterly winds are coming. So high shear over North India and easterly waves over South India. So if you compare it with the thunderstorm maximum pattern, you will note that this easterly waves tend to give a lot of thunderstorm activity over South Peninsula. And here, basically, the westerly systems, the western disturbances or westerly troughs move over the Indian region, and when they come, they totally modify the atmosphere. They bring in moisture from the Arabian Sea. They increase the atmospheric shear. They increase the atmospheric moisture and the lapse rate also, and they cause thunderstorms. So the synoptic forcing for these thunderstorms is more important than local factors. Locally, thunderstorms are inhibited. Only when large synoptic scale systems come in, these thunderstorm occurrence happens. Coming to the pre-monsoon season, if you note that the moisture content has increased, just comparing the moisture with the pre-monsoon season moisture, it has increased, especially along the foothills of the Himalayas, over the Himalayas itself. So, nevertheless, over the central Indian region, moisture is very low. The pre-monsoon season, which we define from March to May, is also the season when the Indian landmass gradually starts heating up. And during this season, over central India, a heat low develops on the surface, which means extreme heating at the surface. But in the upper levels, the atmosphere is still very cold. There are westerly winds coming from the Afghan plateau, and these are very cold winds. So due to that, the atmospheric lapse rate is very high. So I guess you can immediately interpret that the instability of the atmosphere is very high. Low level wind shear, if we talk of, the westerly jet still predominates, and over the southern peninsula, you don't have the easterly waves influence so much, but in the surface there is a north-south trough along the passing through this heat low, which again is very suitable for thunderstorm occurrence. But please remember, moisture is very low. So in this kind of condition, the westerly troughs give this kind of thunderstorms over this region. Over South Peninsula, due to at the southern end of there is a north-south trough. So along that trough, you get east of the trough, you get thunderstorms, and especially over Kerala, you get a lot of thunderstorms, not very severe, but thunderstorms. And over East India, if you note, there is a troughing. There's a seasonal troughing situation where this gives a North Indian dry line, we call it, and this is basically the region with the most severe thunderstorms, which happen during this season. We'll talk more about these thunderstorms later. Coming to the monsoon season, if you note, compared to the earlier pictures, it's all green throughout, a lot of moisture in the atmosphere. So this is in fact the biggest favorable factor for thunderstorms to occur. So they are more frequent, so to say. The atmospheric lapse rate, not very low, but it is moderate. because there is a lot of overhead clouding, so that kind of extreme lapse rates that you see during the pre-monsoon season do not happen during the monsoon season. But nevertheless, it is pretty high. The wind field, if you see, there is a at 850 HP, which is the 1.5 kilometer, again you see a northwest southeast oriented monsoon trough. This is a very favorable factor for thunderstorms to occur, and general moisture being high, the atmosphere is pretty much primed for convection. So if you compare in terms of absolute values also, throughout the Indian region it is high, but along the monsoon trough, if you see, these thunderstorms are the highest frequency. Post-monsoon season, the moisture is gradually decreasing. If you see, compared to the pre-monsoon, it is not a duplicate of the pre-monsoon season in the sense that moisture is still pretty high over most of the landmass except maybe northwest India. The lapse rate is moderate, not as high as the pre-monsoon season, and but again the reappearance of the westerly jet, subtropical westerly jet, is not that prominent yet, but nevertheless there is wind shear is there. It may be moderate wind shear, but in this season also you get the two maxima, that is over Kerala and over Jammu and Kashmir. So this is again the northern maximum is due to the movement of westerly troughs, which bring in moisture into these dry regions, and the southern maximum is due to the easterly waves, the northeast monsoon as I talked to you about, lot of moisture, so frequent thunderstorms. So if you see the annual thunderstorm distribution, we have the highest frequency of thunderstorms. This is for 1 year, but this pattern is repeated from year to year. It is from April to August. So maybe a little variation from year to year, but these are the months when thunderstorms are most frequent. So when you consider in terms of clouds, of course, this is only to illustrate which clouds give thunderstorms. You will note that this is from a paper by Professor House. This thunderstorms are, the mesoscale convective systems, the large systems that pretty much move in to over the Indian region from the and get moisture feeding from the surrounding oceans. These are maximum during the monsoon season, which is June, July, August, September. During the months of April and May, if you note that this region, which I talked to you about as one of the most severe thunderstorm prone regions in the world, in fact, this is the region which starts to get thunderstorms. This matures during the monsoon season, and during the winter post-monsoon season, you start getting thunderstorms over the South Peninsula. This is the region which becomes prominent for thunderstorms. So now when we talk of weather associated with thunderstorms, we come back to the same picture again, but here we see something else. Thunderstorms peak during April to August, that is true, but if you see the associated phenomena, that means hailstorms associated with thunderstorms, these happen during March to May. So this has something to do with the upper atmospheric cooling. So if the 0-degree isotherm is low enough, only then hail frequency is more often. Dust storm days are again more frequent during April to June. So if you see March to May is hailstorm, April to June is dust storms. So slight lag in the dust storm, higher frequency of dust storm days compared to the hailstorm days. So these, when you talk of phenomena, maybe the first thing we need to talk about is high winds. So this is a political map of India. If you see the eastern part of India, Bangladesh, and West Bengal, parts of Tripura, Assam, and Meghalaya, you get something known as organized multicellular weather systems. These are only during the pre-monsoon season, March to May, maybe. These are, if you see, this is a particular instance over Kolkata. So this is maybe around 400 kilometers long weather system, and these kind of weather systems happen only here. Less frequently, they also happen over northern Indian plains. If you remember 2018, there were, in the month of May, there were some very severe thunderstorms and lot of damages over Agra, Gwalior, Lucknow regions. That was because of the formation of these squall lines. Strong winds are expected along with these thunderstorms, and they kind of push the entire, there's a long band of high winds just ahead of the gust front, just ahead of these thunderstorms. They're long-lived, and over East India, they may be over 3 to 4 hours in lifetime. Over this region, maybe less, but nevertheless, huge damage potential. Over the rest of India, we have this clustered multicellular thunderstorms during this season. These, please don't take these lightly either, because their lifetime is short. But if we go in terms of devastation and winds, these are no less, and you do get a lot of thunderstorms, but with shorter lifetimes. So if you see in terms of region affected, these affect less regions as compared to these. So if you see in terms of wind speed vulnerability, this is a combined all India figure throughout the year. The coastal region, let us discount it as due to maybe cyclones, tropical cyclones. But these inland regions where you see these dark blue colors are all regions which face a lot of high winds associated with thunderstorms. So just trying to correlate it with the previous map, you will note that this region where squall lines are more frequent, you have some of the highest winds associated with them. These regions also have high winds, and there is a higher frequency of non-organized clustered multicellular cells that give high winds. In IMD, when we issue warnings, this I'll talk simultaneously because I'm an operational forecaster. We have to monitor it and give forecasts on every 3-hourly basis. We define light thunderstorms with maximum surface wind up to 40 km per hour. Moderate thunderstorms with maximum wind speed between 41 to 61 km per hour. Severe 62 to 87, and very severe in case of thunderstorms beyond 87 km per hour. Coming to hailstorms, if you remember, we talked that hailstorm frequency is highest during March to May. Here too you note that the hailstorm frequency is highest in the Himalayan region, which is different from where the highest winds are noted. So, and there is a smaller maximum over central India. How does hail affect? Of course, it affects human life, livestock, but also damages the fruit orchards, vegetable and field crops. So IMD warnings are in terms of only thunderstorm with hail. So just the prediction of hail itself, it means we issue a red warning for hail occurrence, probable hail occurrence. So if you've gone to the Himalayas at any time, the fruit orchards, how do they protect themselves from hail, which can wipe off the production for entire orchards overnight from a single event? You must have noted this kind of hail nets. So in fact, there are very nice advertisements on the net too for anti-hail net. So once a prediction warning for hail goes out, farmers, maybe if 1 day in advance, if they get a warning, all the more better. They cover all their orchards with this kind of hail nets to prevent damage to fruits like apples and other fruits like peaches, etc. Coming to lightning, this in itself is a big subject for discussion and one of the most damaging effects associated with thunderstorms. They may be, if we define lightning, they may be cloud to cloud lightning and cloud to ground lightning. Of course, for our interest, cloud to ground lightning is more important than cloud to cloud lightning because that affects us directly. If you see the cloud to cloud lightning means within the cloud and intra cloud, this kind of flashes and etc. When a cloud starts to grow, just diverging a little, once it has crossed the 0-degree isotherm, the charge buildup starts. That means generally the negative charge is below and the positive charge is above. So there is a gradual, as the cloud grows very rapidly, positive charge is separated from the negative charge. And as a result, what happens is the neutralization happens. The neutralization of the negative charge as well as the positive charge can happen with respect to ground, or it can happen within the cloud. So cloud to cloud lightning, you have charge neutralization within the cloud. Cloud to ground lightning, neutralization with respect to the ground. Now it has been seen that the cloud to cloud fraction of lightning, total lightning, increases with the thickness of the clouds beyond the freezing level. So once you have a lot of cloud to, when the cloud height is more, this has to come, both the negative and the positive charge need to neutralize with respect to ground for cloud to ground lightning. So with this kind of charges need to traverse a long way to come to the ground. So this is less frequent when the cloud depth is more beyond the freezing level. In fact, it has been seen that the cloud to cloud lightning is about 9 times the cloud to ground lightning in the tropics. That means it is more frequent, like cloud to cloud lightning is more frequent in the tropics, whereas cloud to ground lightning is more frequent in the poles. But this is in relative terms. In absolute terms, cloud to ground lightning is quite frequent over the Indian region. Lightning is not necessarily a negative factor because lightning helps in converting atmospheric nitrogen into nitrates. Generally rains follow a thunderstorm, so they get washed to the soil, and that is what is the natural fertilizer for plants. Lightning also produces ozone, which is a vital gas, and in the upper atmosphere it helps to shield the planet from the harmful ultraviolet sunlight. Now, having talked of cloud to ground lightning, let us see what happens over India. Our winter time weather, if we talk of, when there is not much moisture and the atmosphere is not very primed for thunderstorm occurrence, the cloud height is short, lifetime is short. So there is not much lightning in such clouds and there is low flash density. So this is not a damaging potential. During the pre-monsoon season, cloud height is more. So, but if you remember in our previous slide, that indicates more intra-cloud lightning. The cells are narrow, short lifetime, fast moving. So when it is a fast moving thunderstorm cell, it's short lived. You don't get much flashes from these cells and they grow so quickly, you don't get much flashes from the cloud to ground. The third negative factor, inhibiting factor, is they have less hydrometeors, so less cloud electrification. So this is again a negative factor. You don't get as much lightning potential in pre-monsoon season clouding as compared to the next category, which is the monsoon clouds. So these yellow lines, these are the 0-degree isotherm line, which is the freezing level. So what happens during monsoon season is there is more, the clouds are moderate height. So there is this is around 5 kilometers, this is around 8 to 9 kilometers. So this is a sample cloud, of course, 3 to 4 kilometers above the freezing level, the cloud has enough hydrometeors. So more cloud to ground lightning, and because of moderate height, if you remember, we with more moderate height we expect more cloud to ground lightning. And broad cells, long lifetime, slow moving. So these mean that once a cloud is formed, it pretty much stays there for quite some time. So high flash density over a particular area. The third thing is more moisture means lot of hydrometeors. So more cloud electrification, more lightning. So monsoon clouds have the greatest potential for cloud to ground lightning, which is most damaging for us. This is a picture I have taken from another paper, which shows the monsoon season annual lightning map of India and the sorry, not monsoon, this is an annual lightning map of India and the fatalities due to lightning. So this is the region, if you see these reds and browns and yellows, these warm colors are pretty much the regions where the highest frequency of annual average frequency of lightning related fatalities happen. So you imagine in Madhya Pradesh alone, there are around 300 fatalities, greater than 300 fatalities every year on an average. Why does it happen? That this is the region where lightning fatalities are more. This one reason is, this is generally the path for the movement of the monsoon system. So ahead of the monsoon systems, there are the clouds that we just talked of with more cloud to ground lightning is more prevalent. The other factor is a lifestyle factor. Generally, with the onset of monsoon, our farmers go to the fields and you have paddy transplantation. This is all paddy transplantation area. So here, these are the regions where when the farmer is in the field, he tries to make best utilization of the upcoming rains. But this ground is entirely covered in water, and basically it acts as a huge conducting plate. So once a lightning flash strikes one field, all these farmers standing in the water are electrocuted in one go. So in one instance of a lightning flash, a single flash can kill maybe 30 to 40 people at the same time. So that is what is most frightening for the people. What we issue in terms of warning is, we issue for less than 30% probability of lightning occurrence, cloud to ground lightning occurrence, moderate cloud to ground lightning probability, and high cloud to ground lightning probability, greater than 60% probability of lightning occurrence. These are, of course, various activities that are taken up for education. We'll talk more about this later. Coming to the next phenomenon, which is dust storms and sandstorms. Please note that dust and sandstorms are not a single kind of weather. In fact, if you see, there are 4 kinds that I've listed here. March to June, you have something known as pressure gradient dust storms and convective dust storms and advection of dust plumes from Arabia. And July to October, you have these advection of dust plumes, but these 2 categories do not happen because the loose soil is already tamped down by the atmospheric rainfall. November to February, you have advection of dust plume. This is an annual thing going on throughout the year. And of course, increased in situ burning of biomass and construction activities, you get dust and pollutants in the air. So if you try to see dust, convective dust and sandstorms, this is anybody who's again from north or central or in interior peninsular India must have seen this kind of dust storms. Pretty much the beginning of all thunderstorm events you get during the pre-monsoon season, March to May, you get this kind of strong dust, high winds and dust along with it. This is the region with the, this is in fact, if you see, it is red loamy soil and sandy soil, and this is alluvial soil. This is after the dry winter season, this soil is very loose. So when high winds blow along with thunderstorms, these are the regions where the wind pulls up the dust from the surface, and that is what gives convective dust storms like this. For IMD, we give a warning for if there is a wind speed of 40 km per hour and visibility less than 1000 meters, we give a slight dust storm, but of course more than 500 meters. If there is moderate dust storm, means wind speed is also moderate and as given below, and 200 to 500 meter visibility, and severe dust storm when gusty wind speeds exceed 61 km per hour and visibility is less than 200 meter in the horizontal direction. These are all horizontal direction visibility. The other kind of dust storms that we do see in India, that this dust cloud picture that you saw earlier, you have, if you see this beautiful animation, try to follow this inverted C-shaped pattern over Jaisalmer Barmer region. So there is a low pressure region over northeast Rajasthan. This is a typical case. So on this particular day, there was a low pressure area over this region. So this cloud of dust, this dust front basically moved southwest to northeast towards the center of this low pressure area. So in this case, this is not a localized phenomenon like the previous case. This is large area, maybe 200 to 300 kilometers long, and this gives dust throughout multiple districts of mainly Rajasthan and West Uttar Pradesh. The next phenomenon we talk of is, of course, tornadoes. Tornadoes are also twisters or water spouts. We have water spouts along the coastlines of India during the monsoon season, but during the pre-monsoon season, we get over the interior regions tornadoes. These are severe weather events, and but not as frequent as maybe say United States, but nevertheless they are less noted for the simple reason that they have a very mesoscale area of occurrence. So unless we see a video, we are never sure that a tornado has actually occurred or not. So this is a frequency picture of tornado reports. If you see, April is shown, land-based tornadoes which are devastating over the northern plains. You see, this is most frequent during the month of April and over the East Indian region. But during the monsoon months, you get water spout events along the coastlines of India, mainly over Kerala, coastal Karnataka, Andhra Pradesh, Tamil Nadu. You get a lot of water spout events, which are also devastating, but maybe not as much as tornadoes. Coming to the forecasting of thunderstorms. When we talk of forecasting of thunderstorms, I think we need to look a little bit about the history of how we are dealing with it. As I told you, this is the region with maximum frequency of, this is the season where all India we have the maximum frequency of thunderstorms. This pretty much shows the evolution of the thunderstorm forecasting mechanism in India and of course over South Asia. What started as a small project over East and Northeast India, it was a multi-organization, a national project of India. The IITs were part of it, Calcutta University was part of it, and mostly we dealt with Northwesters during 2005 to 2008. 2009 onwards, SARC adopted this project and it became a multinational project in which India, Bangladesh, Bhutan and Nepal, because the same Northwesters were affecting all these regions, they took up, this project became a multinational project. In 2012, Pakistan and Afghanistan were brought in and the focus shifted not just to East India but also deep, moist and dry thunderstorms, continental thunderstorms over the North Indian region. 2013 to 16 we had the maritime and continental storms in which maritime thunderstorms were brought in and Sri Lanka and Maldives were made part of this project. This storm project, severe thunderstorm observations and regional modeling. 2017 onwards, this again reverted back to Indian project and it is now being conducted mainly by the Ministry of Earth Sciences and IMD, and it has become a forecast demonstration project for thunderstorms. So from 2017 till date, it is being conducted as FDP storm, and from 1st March to 30th June. So pretty much today is the last date for the FDP storm. Of course, the subsequent slides that I talked to you about, the activities continue throughout the year. Only whenever we have new products, more focused attention is given to associated phenomena, because these are the this is the season March to June when the worst thunderstorms happen over this region. So more attention is given to thunderstorms during this particular season. So this is a paper you can refer to about the SARC storm project. So under the Ministry of Earth Sciences, we have had a lot of new initiatives coming. So there have been so many that I have tried to compress them all into one slide. I want to particularly highlight, this is pre-2017, and along with this, these things have also come up after 2017. I want to highlight the Surface Lightning Array Network of IITM and IAF. This data has been significantly improved our understanding of tropical thunderstorm and improved our forecasting capability. In addition to that, the 3DR satellite has come. Of course, then these two satellites, 3D, which was already there, 3DR, they are now giving products 15-minute interval. This is at 30 minutes, this is at 30 minutes, so lagged 15 minutes. Upper air observations network has increased by 13, and we are getting foreign satellite data from Himawari and Meteosat 8. The most significant change that has happened during these last 4 years is mainly the resolution of the global forecast system has increased. Along with the resolution, the newer products targeted towards thunderstorms and associated phenomena such as lightning, gusty winds, aerosol content have come from wind gust probability, hail index. All these products have started to come from mesoscale models as well as from global models for thunderstorm forecasting. And Swirl's nowcast software from Hong Kong Met Office has been adopted and been implemented for 12 Doppler weather radar stations of India. And finally, and this is also very important improvement that has come, GIS-based display of model and observation products. So that has given a more location, has permitted a ease in location-specific forecasts and nowcasts for thunderstorms. So this is a decision tree for forecasting extreme weather. I will go very briefly through each of these steps, but I want to highlight that each of these 7 steps is done every day within IMD with all the products that are available from different sister organizations for Ministry of Earth Sciences. The ministry has, we are being weather forecasters. We are getting a lot of support and cooperation from all sister organizations to go through all these steps to finally generate a weather forecast advisory. So first step is to understand the evolution and past movement. So we see the past weather, whatever has been from different sources, we see synoptic charts of past observations. Next step is to delineate the location, intensity and structure of the weather systems and the forcings. So there again we see more current products. That means we see the radar, we see satellite, we see lightning, we see synoptic charts, and we delineate, okay, this is the kind of weather system, this is the pattern of weather systems we're expecting today. This next step is a preparation of a summary synoptic, dynamic and thermodynamic characteristics. We create a kind of a checklist that, okay, these factors are favorable today, so this kind of weather is likely over this region and it is not favorable for this region. The step 4 is evaluation of model guidance, and in this case we take global models that I talked to you about that are gradually increasing in resolution. 12-kilometer GEFS and UQMET office model, and also WRF model, the mesoscale WRF model running at IMD, and other lightning products, everything we take, and we generate, we evaluate which of these models is giving the best possible current observation of the synoptic pattern, and then which is given the better forecast in the last 24 hours, and then we see where is the similarity between different models towards a common forecast. So step 5 would be basically giving a consensus forecast for from different models and developing a consensus for, this is an important step from synoptic dynamic. This is pretty much the final step before we sit down for a video conference. Now these steps, the first 5 steps, are done by observers and forecasters all over the country, various meteorological centers. They look through the same process we do, but at a higher, finer resolution, and they also look at the state government data, and then we sit down and we discuss create a subjective consensus for the weather forecast for the day. And in fact, we then assign color code, green, orange, yellow, and red, based on the impact aspect of the thunderstorm. So this is the 5-day medium range weather forecast, and for closer to the event, that means every day we also generate up to 48 hours, this is at the subdivision scale, this is at the sub-subdivision scale. That means part of a subdivision is likely to be affected. For example, this is coloring the entire Rajasthan as having dust storms. We pretty much expect only North Rajasthan to get thunderstorms in this region. So then we this gives a guidance. This is a 24-hour guidance, 48-hour guidance. This gives a guidance for the weather forecaster and the nowcaster at the meteorological center level to start issuing nowcasts. So once the regions have been identified, like in this picture, we have identified that these are the regions you need to be focused upon for different kinds of phenomena. Then they start issuing nowcasts based on the event, and those nowcasts are updated on the IMD website, on the media, defense, that means airport, navy, air force, VIP movements, if any, state and national disaster managers, Gramin Krishi Mausam Seva, aviation sector, power sector, cultural sector, everybody gets the nowcasts. And if you see, some of these arrows are dual-sided, so we also get feedbacks from these organizations regarding the weather that is happening. Defense has its own network of observatories. Aviation meteorology has its own aircraft observations and airport observations. So all that observation also comes back to us. So there is a decision tree for nowcasting also. I will not go into it so much as to focus on the stress on mesoscale models and current observations. And using all that, we issue all these warnings. How are the warnings updated? So these are some of the additional products for monitoring thunderstorms, for nowcasting of thunderstorms. Your radar, the biggest help for us, and where radar is not available, lightning, and then we have the satellite, which is again a very tried and tested help for nowcasting, and Swirl's model, which is again for nowcasting. We issue it on the website, which is, like I told you about the categories, rain and snow I have not mentioned, but even they are there. And this is a particular day we issue it for district level nowcasts, 3-hourly updating, and station level nowcast. So currently about 878 stations are nowcast is issued, and here around 721 districts, all the districts of India are updated and nowcasts are issued. What do the nowcasts look like on the these are also issued through SMS. Like I told you, SMS, WhatsApp, email, everything is sent. So because dissemination is a very major aspect for these weather events. So you have sometimes something of the local language also coming into the picture, which gives the a more immediacy to the warning. These are communicated with the state disaster management authorities, district collectorates, media, and then that warning goes to, in every way possible, it is to reach the affected public. The verification, if we talk of, our 24-hour guidance has, its accuracy of prediction has improved in the last 4 years with all these steps that we follow. It has doubled, and 3-hourly guidance also, it has, if you see, it has improved from 2014 to 2019. If we see, it has become maybe 20% improvement as there in the detection of thunderstorms in the nowcast scale, 3-hourly nowcast scale. That was in the 24-hour, and this is in the 3-hour guidance scale. But what is important is timely, actionable warning. Just issuing a forecast that yes, thunderstorms will happen, yes, hail will happen, winds will happen, that is not sufficient anymore. So what we now do is, there is something called impact assessment and impact-based weather forecasts. So definitely for lightning, it is not, I showed a picture a little earlier regarding precautions to take in case of lightning, but in case of winds, our thunderstorms accompanied by winds, we also give this kind of, this is a general impact warning given for moderate thunderstorms, severe thunderstorms, very severe thunderstorms, and hailstorms. These are the 4 categories for which generalized warnings are given, but customized warnings for when we are issuing nowcasts is very important, and that is being issued. Of course, then that question comes, is it acted upon? Honestly speaking, I have taken this as just as an example. Of course, this was 1 day forecast. So this is from 6 to 8. There was a weather advisory for Jammu, Kashmir, and Ladakh. On the basis of this IMD forecast, the district administration of Leh has immediately taken action about what to do. And this is not for one district alone or one state alone. Believe me, we get a lot of support from the state disaster management authorities, the state, the district collectorate offices. Everybody helps to transmit these warnings. Our important aspect of our thunderstorm forecast is interaction, feedback, and analysis. These are the 3 main things we focus on. Pre-season exercise, because even now, like I told you, if 110 farmers are dying without, despite the forecasts improving, so there is the last mile gap is still persisting, and here we depend a lot on our media colleagues and state government authorities who conduct different activities to educate, to make the public conscious about the actions to be taken. I'll come first to the 4th point, which is post-event and post-season analysis. So whatever has happened, did we go right? Did we go wrong? Where did we go wrong? And it is not just the forecast, but the impact assessment also is important. But here we have a little problem where we need feedback from the public. We need feedback about the weather event and the impact, because oftentimes it is so mesoscale in occurrence. Our observatories are so far apart that they are not able to give information of maybe a tornado that has happened. So we can get this information only if we get cooperation from the public and the media. I'll end this presentation with 2 slides. Thunderstorms, thunderclouds are not new. These are everywhere in our literature, in our music, in whether in our poetry, maybe 1600 years ago, monsoon onset, or thunderstorms over South Indian Peninsula, or dry thunderstorms over North India, or the majestic nor'westers over East India. They have figured repeatedly in our poetry, in our language, in our food, in our habits, in our music, in every aspect of our lives. So I wish you all the best, and I hope you will continue to watch out for thunderstorms and cooperate with all of us in providing accurate, impact-based thunderstorms to prevent this kind of events like this Bihar event from recurring in the future. Thank you.
Thank you, Dr. Soma Sen Roy, for a wonderful talk on thunderstorms and storms and lightning. So we have kept some questions for you. So come out of this, the slideshow mode and please answer those questions.
Okay. I think I'll see the first question. There is 3 main areas of frequent lightning, Jammu and Kashmir, Northeast and Kerala, but most of the deaths are reported in UP and Bihar. What could be the reason for this? I do not know whether, I mean, if you have been following this presentation, much of these deaths are due to lightning. And if you really see the frequency of deaths, they are more frequent during this season, I mean, May, June. 2 things happen. First is lightning, and its frequency increases during this period, but also simultaneously farmers go to the fields, and electrocution is a major cause of death associated with thunderstorms, and also winds. The winds are, even though they are less frequent than you think of, a single wind event can can make projectiles out of building roofs and cause widespread destruction. So that is again a reason why, and this is the region, UP, Bihar, where both factors are most prominent. Hence, the most casualties are from this region. Second question is, please provide information about platforms or government website from where we can get spatiotemporal data of lightning flash and thunderstorm over Indian subcontinent for our analysis. So what should I do? Should I give this? There is a website. Should I give a link to this particular website? Can I'd like to ask the moderator, can I type out
Madam, I think you can just mention about the website if the user may contact you later on for offline discussion.
Okay, that is better. I think so. I think there is a website. The lightning flash density is there, and it is displayed every 15 minutes. It is updated, and it is there on the website. Please look into it, and if you have any queries regarding the data, please talk to IMD, and we shall arrange for you to be contacting the necessary person. Actually, IITM has the data. Indian Institute of Tropical Meteorology, you need to contact them for the spatial temporal data for lightning flash and thunderstorms. How a lightning flash is detected? Is there a dedicated instrument which observe or use study of plasma created during lightning events in the atmosphere? Yes, of course, there is lightning. You have lightning detector networks, which basically detect the electrical disturbance in the atmosphere and accordingly gives a lightning forecast. Now, what happens is, if you have 4 such, of course, I'm going a little into the detail. If you have 4 such detectors, they detect the same disturbance in the atmosphere. Then you can get the X, Y, Z, and T aspect of this particular lightning flash and intensity also the lightning flash, and accordingly you can get the 3-dimensional location time of the lightning flash. Are the science dynamics favorable conditions same for thunderstorm and hailstorm? Are the thunderstorm indices used for thunderstorm study will work for hailstorm? Oh no, of course not. All thunderstorms are not associated with hailstorms. Actually, if you really see, hailstorm itself is a very complicated phenomenon. For northwest India, for example, when we see the hills, we have a general thumb rule. We follow around 700 HPA isotherm means, and the thunderstorm happening with a 700 HPA isotherm, that means around 3.1 kilometer isotherm means we expect hailstorms to happen. This is generally true. I would not say always true, but not all thunderstorms are associated with hailstorm. Severe thunderstorms that happen over the plains, that can also, even if the isotherm is much higher, there can be hailstorms, but again we need to see a lot of other factors. Hailstorms indicate that there are severe thunderstorms in the vicinity, so that needs to be looked into. What are the skills of IMD's lightning prediction and lead time for such prediction? Okay, I will answer the first point is what are the skills of IMD's lightning protection? IMD does not issue, the problem with lightning warnings is that we are issuing lightning warnings, not just lightning, thunderstorms and all other phenomena. We are issuing warnings every 3 hours and updated in the middle of that 3-hour window also if there is a probability of increase or decrease of the weather. But verification of lightning per se is only, lightning alone is not being done. Entire thunderstorms is being done along with all other phenomena clubbed in together, because we don't get that location and the methodology for lightning verification is a little more complicated, which we are trying to implement, but it will take a little more time. And lead time for such prediction, it is 3 hours minimum. It can be an hour if necessary, and spatially it can be a district, a block. Wherever lightning is more probable, it will we give a lightning prediction, lightning and thunder prediction for that. And especially for this Bihar event, we see we have been given lightning warnings. Bihar and East Uttar Pradesh, lightning warnings, frequent cloud to ground lightning is expected over these regions. So that is already being done. The only problem is the last mile dissemination is still a problem because of the various weak linkages on the way. This is a developing field, and we need help from all of you to see to it that this becomes this reaches the poor farmer who's working on the field, who's most affected by lightning. Thank you. I think these are the 5 questions.
Yeah, thank you. Thank you for answering the queries, and thank you for spending your time with us for the MoES webinar. Thank you very much.
Okay, thank you, and good day.
Yeah, so we can go offline now. Thank you.